Thank you, Karen. Yeah, I'm super excited for the summit. I'm positive it's going to be such a great experience, especially after the last couple of years. So that's a lot of fun. Hi, my name is Adi Palak. I'm a VP of Developer Experience at Treeverse, the company behind the open source LakeFS. I help build LakeFS. I also help educate the community and work with you all on learning how to build better data lakehouse, distributed machine learning, and all this good stuff. And I am super, super, super excited to be here today and learn together as a community. All right, passing the torch to Danny, which I think you already know pretty well.
No. You're the star of the show, Adi. So, well, hi, everybody. Thanks very much, Adi. Glad to always hang out with you and Karen. My name is Danny Leaf. I'm a developer advocate here at Databricks, longtime Spark and Delta Lake guy. So here to answer some questions and talk about coffee and mechanical keyboards, apparently, as well. So that's my spiel. So, hey, Adi, let's dive into it. And for everybody that's actually on LinkedIn, Zoom, or YouTube, we will be looking at all of your questions and we will try to answer most of them live. So if you've got questions that are related, primarily related to LakeFS and Delta Lake, please do ask your question. Now, if you happen to also want to talk about coffee and keyboards, yes, we can certainly go down that rat hole, but we do like to limit to those specific topics if that's okay today.
Well, we can talk about anything. I mean, because we can, right?
Well, it's true, but I still feel that, we will rat hole really easily. So that's why I feel that, like it's dangerous to offer that up. That's all I'm saying.
100%. All right. So this is not going to be a traditional session. This actually is going to be a conversation between Danny and myself. So I'm sharing my screen and we're going to go over some very interesting scenarios of some of the new challenges we're seeing in the space of data lakehouse, building data pipelines, and how do we combine all of this good stuff together. So what you're seeing here is basically a more complex screen. I actually have 3 screens. 2 of them we're looking into Databricks Notebook, where we're going to challenge our data a little bit and see what we can get out of it. And at the bottom right, you can see the LakeFS UI, which actually enables us git-like capabilities or git-like interface over all the data that we work with, all the tables and everything that we're doing with this type of operations. All right, let's get started. So what is a data lakehouse? And I think, Danny, you're probably the better person to explain that part. But as far as I understand, as far as I see it, it's basically combining some of the best elements of what we see today in data lakes and also data warehouse into one platform. So it enables us to do all the computation, all the management aspect, views of tables, and a lot of great stuff that's related to both the complex data lake, the scalability of the data lake, and also the traditional old-fashioned data warehouse. So basically taking the data warehouse at a much larger scale with much better capabilities. Danny, would you like to add some stuff to our
Absolutely, though. I do feel, attacked a little bit because you said I'm old-fashioned because you are calling out my data warehousing roots. So what do I mean by that, outside of the joking fact? So I actually used to work as part of the SQL Server team, Microsoft, a couple of lifetimes ago. And of course, during that time, everything we were trying to do was trying to shove everything into a data warehouse. Everything was about the data warehouse. We figured out how to do everything using cursor operations, which of course is gargantuously slow. Like this is like the worst idea ever inside a database, but we were trying to shove everything there. Anything that was semi-structured or unstructured, we would figure out how to structure it. And I'm using quotes if you can't see it, to get it inside the warehouse, because everything was about chucking everything into that database and using store procedures and trying to speed things up. And in reality, what it came down to, and that's why we made that, and that's like the version 1 of the world. And then the version 2 of the world basically is like, no, we don't need schemas at all. We'll just chuck everything to data. Like we do not care about that stuff. It's fine. And while that gave us a lot of flexibility that Adi was basically referring to, what it meant is that we actually had no structure to our data at all. And so it became really, really interesting, in which basically a single table would end up having 8 different schemas. And so nobody knew what they were querying, basically. So this idea of a lake house, and some of my friends will actually say, dude, that's just a marketing term. It's like, well, fair enough. I'm not going to dispute that statement, but it's also true. right? Which is taking the best aspects of what a database and data warehouse has and taking the best aspects of data lake. So that way you can actually, using the same store, both handle structured and semi-structured queries at the same time, allow yourself to do machine learning, streaming, all using the same storage platform. And that's the key aspect here, right? The idea is that you don't want to replicate your data multiple times over. You don't want to maintain different systems to do all of these different data paradigms. Instead, it's about going ahead and actually having this one concept, one foundation for all of your data paradigms. So hopefully that helps provide extra context, but let's just dive into Delta Lake and LakeFS.
Yes, let's do that. So actually in this scenario, what we have 3 different tables, and we're going to dive into it in just a second. But I want to go over before that about what is Delta Lake and what does it provide us. And of course, there's a lot of more features coming up on the roadmap and a lot of great things that the community is building together with Danny and the rest of the folks. So it provides us with availability. Availability is something that is very crucial for us when we're thinking about data lakes and when we're trying to build an environment where we can actually trust the data that we have there to be there, right? So we want to make sure we're adhering to ACID compliance, we have the ACID compliance, but also making sure it doesn't hurt our latency of streaming and the batch data pipeline, specifically the streaming one, because we always try to make it as fast as we can so we can reach those SLAs that we want to reach. So that enables, this is all the things we can do with Delta Lake at the moment. And of course, there are more things coming up wonderful things coming up on the roadmap. And then what is open source LakeFS? So LakeFS, like I said in the beginning, provide us with a git-like version control interface for the data lakehouse. So that means it can integrate with all the different data lake table formats that we have that we want to work with. And on top of it, it gives us that exact interface so we can work with the data pipeline and work with all our data in the system, just like we would do with Git. So the same thing we do with code, we can do with data. So it enables us to create experimentation. One of the big challenges that we have today in the data world, that it's very hard to test real volumes of data. A lot of our tests are kind of integration tests, system testing, and it often fails on some specific use cases that we're missing that actually exist in production. So it enables us to do these exact experimentation in an isolated environment over real volumes of data. It also enables us to do reproducibility, because once we establish that branch, we can always replay it and run it again and again until we reach the good results. And that actually opens a whole new world of CI/CD, continued integrations, continued deployment for data. And what does that mean for us as people who are building data pipelines and complex logic into our system, such as cross-collection consistency, for example, where we actually need multiple keys and we're doing building our logic is much more complex than just do a simple search. So LakeFS enables us to do it in an isolated environment, and like I said before, it works on multiple storage type, multiple object stores, and also on Delta Lake. So it actually complementary together, so it works really nicely. And it's compatible with S3. So if you're working on AWS or also on Azure or also on Google, it has this compatibility. So what is cross-collection consistency? And this is one of the things we have to nail today and everyone has to understand. So it actually speaks of if I have multiple data streams and I'm processing that data, a lot of the times I need to do a complex logic that relates to the collections that I already have in the system. So I have data flowing into my system, I'm collecting it, but then I want to do some cross-collection, some computations on top of it. So I want to build some unified view of some accounts, some users, or anything that I want to measure in my system. And I might want to introduce it in different formats, in different ways, or change the index. A lot of times we have like first, secondary index, first index. Sometimes you want to change it for performance. So there's a lot of work that we're doing that relates to cross-collection consistency specifically. And this is what LakeFS enables us. LakeFS enables us to branch out. If imagine that I have a stream of data running in my production. This is my data pipeline. I am able to branch out of that stream of data, out of that main pipeline of data, into a secondary branch, into a side branch, run my experimentation, even if it holds multiple tables with multiple transactions, and then decide if I want to merge it back into my main pipeline. So that enables me this isolated environment to run my experimentation. So this is where these things comes together. So I can actually, at the granularity of a table per se, I can work with Delta, right? It enables me time travel, it enables me update, merge, a lot of great operations that I can do with Delta. And then if I want this to be on a larger scale for the whole data pipeline, assuming I have something more complex with more transactions, then I can combine Delta Lake together with LakeFS to enable this isolated environment where I can actually tweak every piece on the way, but also tweak the whole, the branches, all the pipeline as a branch. So this is a little bit where it's coming from, and I see we have questions, so that's exciting.
Cool. So, Adi, as you refer to the questions, one thing I definitely want to overemphasize about the importance of this concept of cross-collection consistency, right? In most examples, especially when we're running demos live, right, we're really only showing maybe one pipeline, right, or one set of tables being processed, right? But when you're in production, you actually have to look across the entire system, right? And typically are multiple tables processing data, multiple sources, multiple unions, joins, business logic, things of that nature, right? So because of that, this is where this concept of, is the entire collection of data that you have basically consistent at any one point in time? So in other words, you've got table A, table B, table C. Are they, when you're about to do the join, are they in fact, are you not going to have dirty snapshots, basically? Are you actually reading the correct data and joining the correct data and applying the business logic to the correct data? And so that's why this entire concept is very important. So I just want to overemphasize that fact. For earlier, I think early last year, and hi to the cat. Woohoo! All right, the cat made it. We did actually already a previous session about multi-table transactions using LakeFS, and so that is a simplified version of this concept of cross-collection consistency. Hopefully, I got that right, Adi.
Yeah, 100%. You nailed it. This is exactly it. It actually enables the two to work together and really level up everything that we can do with data and the data pipelines. So, whoa, I see it's a little bit storming outside. This is our example for today. We actually have 3 different tables. One is loan by state, second one is loan details, and the third one is loan payment. We brought it in from Kaggle, and we already have our data loaded into Delta Lake tables into a LakeFS branch. So you can see it in here. This is my LakeFS UI, and I'm already looking specifically at my repository at the BI report, and my cat is here making sure we're getting it right. And I can actually go in between the different branch and look at the data from different angles of the whole pipeline that I'm working on. So that's really cool. As you can see, I didn't do any changes at the moment, so revert here is not working yet, but we are going to introduce some changes, and then we'll see how we can revert all this operation on all over the different tables that we're operating in. So not only one, but we can actually do it on the whole branch. Cool. So I have my Delta Lake silver path, and I have already my BI reports, loan by state. I know I'm looking into the LakeFS, which looks into the Delta Lake, which looks into S3 as an underlying storage. And I can already see and go over my data. I have my loan by state. I have my loan payment. I can insert new values if I want to. And I can start actually tweaking and playing with select, create table, so making sure it's available to me from Hive Metastore as well. Describe, if I want to describe the details of Delta as well, I can easily access it. I can access the query Specifically here, there is nothing in my loan by state, and that's okay. And then we're hitting the more complex things that relates to Delta Lake. But before that, I actually want to add one small thing here. This insert. I want to make sure we're running it and we're having more information in our data. So loan payments, I added more information, and in my second notebooks, it's kind of like my analytics UI or kind of a dashboard, and I'm trying to see everything that is happening in my data, in my table. So here I'm just counting the rows at the moment, looking at the loan by state, and then looking at the loan payment to see how many rows I have in it. Cool, so now I have 3, now I have my loan by state, 54. So we're going to tweak the data a little bit, and we're going to play with it. And we're going to play with it using batch and stream because we can, because it's more closer to how we're really going to work with it. It complex things a little bit. It shows us the great power of Delta Lake and how these two works great together. So I'm starting to run it, and then I'm going to look, then we're going to take a look at how it looks like when we process it. We're going to give it a couple of seconds to load. To get it warmed up a little bit. And then we're going to start digging into inserting more information and playing with the data. By the way, loan data set is probably not the most exciting one.
No, it's actually pretty boring, but it's a good one for us to work with because it's small and accessible by everybody to go ahead and play with. So that's why it's a fun little data set that allows you to just basically test things out without actually trying to build an entire production pipeline, basically.
Yes. And you can see like the first minute I start entering data into my system, a LakefS already capture it, so I can always revert if I need to for the whole branch. Not only one table, for the whole thing that I'm changing and experimenting with. So just to give you a heads up, fun things are going to happen. Yeah, and then we want to insert more information. And you know what, we want to make it more programmatically nice because we want to insert more than one line, right? And we can, thank you. And then we can actually start looking at the stream and what's happening as we populate that stream. And we're going to work with the great map visualization that we have built in. And we're going to see how it populates it and how it looks like when we're adding more and more information related specifically to the state of Iowa, because we can.
By the way, there was no particular reason we chose Iowa. By the way, I just want to call that. So in case there are any Iowans there, I actually did used to live in Iowa City, so I think that's why we chose Iowa. So just in case people were wondering, there was no particular reason outside of that. So
yeah, absolutely, it's just the way it is. Cool. And then we're getting into the most exciting part. I think that's the data manipulation language, right? This is the more unique parts of Delta that enables us to do all the update, delete, merge, and all the things that's usually very hard to do with data lakes specifically. So we can actually, let's see, Iowa is populated here. That's cool.
That's a lot of loans for Iowa. Wow.
Right?
Yeah, that's a lot. Yeah, that's pretty huge actually.
Well, how many houses can we count? How many apartments? Rentals. Great. Okay, so now we're entering into the data manipulation language that we can do. And one of the great things we actually want to show how Delta Lake is very different than the traditional Parquet. So Parquet is a columnar storage that enables us to store to store all our data by columns. So it's fast, it provides us fast access when we're looking for specific columns and we want to query the data. So a lot of the times for query processing, we want to use Parquet. If you're heavy users of Spark, most likely that you're using Parquet as well in your data, as your data stored. So now we actually want to show how is Parquet different than what we have and the different operation that we have with Delta Lake. Because Parquet specifically doesn't allow us to run any delete statement. So now I'm building this loan by state PQ, which speaks for Parquet. And I want to try and delete some of the data out of it. So I actually want to delete all the data in Iowa. And it's failing. And it's failing for a reason, because delete is not supported by Parquet format. So what can we do? We can use Delta Lake, right? We're looking at this table, and we know Delta Lake enables us to do delete from the table. So we actually can leverage running SQL inside the Databricks notebooks to run that delete from loan by state, and that works. That's great. And then we can just look at it, because we can, and we can look at the data and look how things change. We're not going to dive into the specific of the data, because just loans are boring. Another, being honest.
Yeah, no, that's fair. It actually is a boring topic. So yes, but I think the key context is what's nice, and as Adi has called out, is that you can run DML statements like update and delete with Delta Lake, as opposed to needing to worry about how you have to do with Parquet, because the thing will just simply fail, basically.
Exactly. And the second thing is we can run update, right? We've never had update in Parquet. It's like one of the things we needed sometimes, because you have to come in here and say, I have this file, or I have this row, or I have this entry that I must change the columns there. And then there's a lot of manual work of, copying, changing, exchange, all of this manual work that a lot of developers are doing, copying all their data, changing that's just very specific things. So here, actually, the Parquet one would not work, but the Delta one would. So that's great. So that enables us to update the data as well. And I think one of the most interesting feature is actually the merge into, and that takes us back to the days, well, at least me, back to the days of Oracle a little bit. And Danny, I'm sure your SQL days are as shiny as mine. But actually merge is very interesting functionality that kind of combines that insert and update. Sometimes a lot of people confuse it with join functionality that can take place. It actually enables us to merge more information into the table. So if we had a legacy data pipeline, and we want to insert or update anything related to the table, we'll have to identify the rows. We have to find them and, of course, identify and replace them. And then try to create some temp view related to it, do some processing with some statement, and then save it, delete the original table, rename the temp back. So there's a lot of manual work when we're working in the space of data lakes and scalable data. And here what's nice is that it actually, the merge does it for us. So let's assume we already have a table. So I'm just now creating a new data frame on the fly, because we can, and we can take a look at it. And then we want to merge it. And if you can see here, the merge into actually make sure we're merging on the keys that we have in the table. So here is sometimes we're missing when we're using wrong keys, and sometimes we can miss when we do merge, for example, on data that is corrupted. So for example, if I'm getting stream data and batch data into the system, and then I want to do the merge on top of it, sometimes there might be that the data itself is corrupted. So a lot of weird things can happen along the way when doing merge on data in production, especially if it's programmatically in my code. So many times we want to be able to have a good set of testing and tools around it. Cool. So we did the merge. It looks great, but now we want to take it, we want to level up a little bit, right? Because we're talking about leveling up our data lakehouse. So we want to do merge schema. And merge schema is often some of the cases that we see a lot with machine learning and the more advanced schemas, because we want to be able to support more columns in our data. We want to be able to support different type of columns in our data as well. We want to be able to support the evolutions of schema as we go on the fly. And Delta enables us to do that exact thing. It enables us to do the schema evaluation when we configure to do the schema evaluation. So here, for example, we're just displaying a table's name loaned, and we can try and append it back to our Delta Lake Silver path, and it's actually going to fail. And it's going to fail because we didn't tell it that now we're doing a merge schema, because a merge schema is an operation. It's a little bit more expensive. We need to be a little bit more cautious when we're doing that. So when we're defining that this is the action that we want to take with merge schema, we're providing that configurations back to Spark, and Spark takes it from here and knows what to do together with the Delta Lake. So let's assume something happened in one of our tables, and we want to know what happened, and we want to be able to travel back. And a lot of the times we want to be able to audit these data changes. We want to reproduce some very specific reports or experiments. You want to roll back on specific tables. And the way we can do it with Delta Lake specifically, we can actually describe the history of the thing. So again, I can go table by table and see what happened to that specific table as I go. So I can see the operations, I can see the user ID, timestamp versions, and all this good stuff. So if I want to travel back in time to a specific version of a specific table, I can do it. So let's say I want to go with version 2, for example. I can grab a snapshot of this table in version 2. So loan by state, I'm selecting it, and now I can look at how it looks like in version 2. And in version 2, I have the write operations. Let's say I want to look at a different version. Let's say I want to look at version 9, for example. So I can actually go back in time and look into version 9 using same syntax, same operations. And now something very severe is going to happen because I deployed a new data pipeline into production and I had a bug and something happened. All the tests were red, but for some reason, you know, I said, let's go with it.
That you forgot to put the where clause, so all of a sudden you deleted the table. That's never happened in production, ever, never. By the way, if you can't tell, both Adi and I are scrunching our noses, basically denoting a massive amount of sarcasm. just want to call that out. So
yeah, it never happens that I accidentally delete something in production. It never happens that, you know, my complex data pipeline turns out to be a fantastic data pipeline. Everything works and I never do mistakes. So let's assume I actually deleted that loan by state somehow because my pipeline is complex, because I have schema evolution, because I have this merge operations between different data sources and data collections, and something terrible happened. And this is actually because of the complexity, because that we're looking at the branches as a whole, you know, that holds all of our operations that we do with the data. This is where LakeFS saves the day for us when we want to make sure, you know, we're safe and we can run efficiently in production. So all these operations across 3 tables, we can decide if we want to go one by one and start finding the culprit, which is probably something we do want to do because we want to make sure we're fixing it. But also we want to be able to give a fast remedy, a fast response to the data, to everything that happens in production. So when looking specifically at LakeFS, and I'm going to refresh it, this is the LakeFS UI. I'm in the repositories. I'm under the BI report in repositories. I'm under my branch that I configured because I started. I'm a responsible engineer. I started my experiment before I'm pushing to production. I want to test all my logic on the real data volumes. So I created my own branch that uses a zero copy mechanism behind the scenes because I want to be able that if accidentally I do a delete command on the wrong things, and that happens, I'll be able to revert back and let production, without harming production at all, because it happens in an isolated environment on real production volumes data. So here I can actually see the, just like in Git, when we see in code, I can see the thing that got changes. I can see the success file, right? This is a magic file that tells us what happens. I can see the snappy and per cat. I can see the Delta log, the change, right? Because we did a lot of transformations, we did a lot of work. Delta logs holds all the different changes that happens to the data, so we can actually, travel back in time on that table. So here it holds everything together. And if I want, I can just say, all this branch revert or commit. Let's say I'm happy with the result. Let's see. So I can go back into my UI data that kind of does the testing for me. For example, let's assume I have fantastic testing running in production, all the great webhooks, making sure I'm not doing too many mistakes. So we had 54 and 3. Let's see what's happening in our data. Now we have 58. And let's look at this table. Now we have 0. And actually, I need some, information in it, or maybe a different information. So I can actually go back to LakeFS and say, you know what? I was wrong. I need to go back and study.
You need to go back and actually bring it all back. Yes. I
apologize. And then I can actually, after I'm done doing revert, I can actually look again at my data and see it reverting back to where it was in the beginning, before I started my work, before I deployed this monstrous data pipeline complex into production. And this is the power of combining LakeFS and Delta Lake. It enables us to really dive into multiple granularities. So we have the high level of what's happening with all the cross-collection consistency, but then, we can operate on that, but we can go really deep into the different versions, what was changed together with Delta Lake. So it enables us this great combination. And one of the nicest things is that both of them are open source. So we can take it and we can install it. Of course, we showed it on a Databricks environment because there are fantastic notebooks and it's always easier to see it there. I personally enjoy the notebooks. It always makes my life a little bit easier. But it can also
we have not paid Adi to pitch that, by the way. I just want to call that out.
No, that's no, it just, the notebooks are great. But this is all available as part of the open source. So I think they are a match made in heaven.
Definitely, yes, and that's why we actually have a session like this. And so, I think the key questions, some of the questions is, first of all, Adi, do you think we'll be able to share this notebook so that way more people can go ahead and start testing this out? And I figured the answer is yes, but I do think we need to do some quick updates since there's this standard. We did this really quickly. We did this up to a couple hours before the actual event. So yeah, let's clean that up first, and once we do, we'll share the notebook. What do you think, Adi? This sounds about right.
Absolutely.
Perfect. Any other? Let me start diving into the question. So this is a great question from Prasad here on Zoom, actually. So let's see. Oh, sorry, I'm actually looking at the wrong. Oh, sorry, no, from Yusuf first, then Prasad. Sorry, Prasad, I will get to you. I just Yusuf asked first, so I want to actually ask this question. Are there any situations where LakeFS actions are tied back into, I guess he's specifically talking about Databricks clusters, but I'm just going to say in Spark clusters in general, via their REST APIs, something like a data quality pre-merge hook?
Yeah, absolutely. So we have LakeFS open source enables webhooks on top of these Git branches. So a lot of the usage that we see, how people are using the open source, is they're actually building multiple quality logic. So if using YAML or a JSON file, you can build that webhooks and actually leverage the fact that it provides you with a great Git branch interface to run this testing, just like in a CI/CD world with code. So yeah, you can do it. You can also do it on the Databricks environment if you're combining the two, so you can build it there as well. So yeah.
Excellent. And then now to Prasad's question. So don't worry, Prasad, I wasn't trying to ignore you. So he asked a really good question, which is, so does, in the case of LakeFS versioning that you just demoed, right? Are you versioning the S3 objects themselves, which comprise the data inside Delta tables, or what are you doing in order to allow that type of functionality that you see here?
That's a fantastic question, because that means we're diving into mathematics, and I hope you're okay with that.
Yes, let's talk about math. I always love it when we go there.
Yes. So we have, in my opinion, a very interesting data model. Usually when we look at databases, we like to talk about B trees, B plus trees, all these wonderful things that allow us to fast index for the primary and the secondary index, and sometimes even more than that. But in LakeFS, we're using a totally different technology altogether. So we have the Graveler file. This is what we're describing. It's, in my opinion, an innovative data structure that allows us to save information in a hashed manner. So we're hashing the values, but we are not making it, we're not building it so it's fast to search. We're building it so we can only keep what got changed when things are changing. So when we're looking at trees, going back to B plus trees and going back to that world, if B plus trees allows me a fast access to blocks or to data, this actually enables me to understand what was changed in a very specific file. Because what we're doing is we're doing SHA-20 SHA encryption, SHA hash, basically, on the value bytes specifically. And then it saves everything in a Markov tree. A Markov tree is a cryptographic tree, which is, again, very different than the rest of the trees. So if you want to learn more, and I do encourage, because I believe a lot of the mathematics and a lot of the things behind the scene are actually impacting how we work and all the functionalities that we are able to build on top of it. So I invite you all to take a look and learn more, and also ask questions.
So I'm just curious, actually, when it comes to, you've actually called it out inside the docs here. You said RocksDB compatible SS table. I'm just curious, with the SS table Graveler, is that information, does it have to go into RocksDB? And by the way, I do want to preface, I love RocksDB. So it's not that I'm against RocksDB, quite the opposite. I love RocksDB. So it's more a matter, is RocksDB a requirement in this case, or is it just more about compatibility? I'm just curious.
It's more about compatibility. And because it's an open source, everyone can go and, build their own version or build their own plugin and work around it. So this is what we thought going to provide very good performance, right? So this is what we provide as part of the open source. But yeah, I invite everyone to dig into our open source code and start figuring out, and also learning from LakeFS docs about how it works. I think it has some very innovative approach to working with data, and the way it enables that git-like operation or git-like interface on top of data, I find it fascinating.
Definitely. And just to, again, overemphasize the point, RocksDB does rock. That is a great choice, by the way. So it was more about the context of if you necessarily need to do it. There are plenty of us who are in the data engineering community that we actually regularly use RocksDB to, basically due to its low latency. And this is exactly why, I'm pretty sure that's why LakefS chose that, because of the super high, low latency, high transactional throughput that RocksDB provides. So. And yet, no, we're not being paid by RocksDB either. This call out. So.
Yeah.
Cool. We have a couple other questions. Some of them are specific to Databricks. And so for the ones people who are asking questions specifically about how to use Databricks, or for example, Azure Databricks Explorer, I wanted to say that, no, today's session is very much about LakeFS and Delta Lake. So if you have those questions, please join Databricks community. That's a great place to actually ask those questions, where you actually have plenty of Databricks personnel answering these type of questions. I can tell you up front, when it comes to Azure Explorer and caching, yes, there is possible to disable caching if you need to, but again, you probably want the details. So again, go to Databricks community to ask those questions. We're here very much for LakeFS and Delta Lake today. So cool. I think we actually did answer all the other questions. Am I missing anything, Karen, that I might have accidentally missed?
I don't think so.
Okay.
Looks like, yeah, I think we're good. I'm just looking at the chat. One just came through. One more just came through.
Oh, right. Can you show the Delta table data files before and after you delete the data from the table? We'll probably have to rerun the entire demo, so it's probably a little tricky for us to do that right now. But suffice it to say, remember what Adi said. It's a zero copy mechanism within the LakeFS Git structure. So it's not like they're actually copying all of the data. If they did that, that would be really slow. So instead, just like, again, Adi called out, right? The context is that the deltas, oh dear, the changes that they see in the system are recorded, in this case, the SS table that LakeFS has. And so because it does that, that information is small and can be, in this case, a selling RocksDB, stored in RocksDB extremely quickly. The data files themselves stay the same. So there was no changes to the actual Delta Lake files themselves. So, and remember, she also ran this on her own branch. So the idea is that all of this is running on her branch. And so when she reverted that branch, all she's doing is saying, okay, that's it. This branch no longer exists. Go back to the original version, and allows Delta to actually revert back to its own set of files as well. So bam, you're good to go. So that's the context that's going on. And so hopefully that helps. Once we do have that demo notebook, then you can probably recreate it yourself pretty easily. It's just that bummer that you didn't ask it while we're doing it, so then we could have shown that happening live. So sorry about that. And I think we have time probably for one more question, and that's for you, Adi. Is there any best practice or guidance on LakeFS branching strategies, like in terms of when you should branch, when you shouldn't? Any good call outs, you think?
Yeah, this is a fantastic question. I think every time you're changing, well, first of all, you can run a CI/CD, like automate all that process in production. So basically, you can make all your data, you can branch out in all your data pipelines in production and add the webhooks for testing before you're merging the data back into the system to make sure that you have quality data, at the end of the day. So you can run it there. This is like I think the best thing to do when you're building today data pipelines, and you want to make sure you have enough testing, and you want to make sure you're separating the testing specifically for every data pipeline from the code. Because what we see today, for example, if I'm deploying a new Spark job, my Spark job run testing in the beginning, and my Spark job would probably run some tests at the end to make sure I'm, there's no schema mismatch or anything's happening in the place. So actually, we're separating these and saying you can use LakeFS mechanism and build those webhooks, so you can actually add these tests on the fly without deploying discharge to production. So it enables you it enables you a better way to actually manage the data that runs in your production, because it provides that capabilities and because you can automate it. So this is, I think, one of the best practices to actually make sure it works together with each of the data pipeline. In case something is happening, you always able to go back and revert and inspect and do all that work. If you're looking to start small, and this is often what we see is experimentation. When I'm building, for example, a new notebook, I want to try out a couple of things, but I want to run it on real production data volumes, then I can leverage LakeFS, just like you've seen today, to test out my logic on the real volume of data. Because often the testing, the end-to-end testing, the system testing, the integration testing only capture some percentage of the bug, and we see a lot of code getting into production that actually corrupts data and makes more problems. So this is like the later version of things. So there is a big range between the two. So I always advise on start small, start running the open source, and we have a good step-by-step explanation of how to get started, and also join our community. Of course, if you have any technical questions, we're here to support, and also if there are any suggestions for new features, we're always happy to take these and help people build LakeFS in their systems. And start small, like start by exploring it locally on your machine. Insert some data, see how it feels like, change the data, do the revert, do the branching, get a feel for the system, and then slowly start integrating it into one pipeline or one use case or one thing, and see how it works for you and how it works for the team, right? Because we are part of a team that we work together. And then see how it gives you the value of actually being able to take back control of what is happening in data in a more complex world, such as the data warehouse.
Perfect, Audie. And I do want to actually end with my little tidbit, just a call out to actually also LakeFS. Specifically, if you look at the bottom of that document, by the way, there's a call out to if you want to get involved with the with LakeFS, they are starting to work on using the Raft consensus algorithms to actually go ahead and deal with much larger systems. So for all of those who are into building distributed systems, actually working with Raft is actually really cool, by the way, and it's a lot simpler than dealing with Paxos. So really cool call out. I think it's a pretty interesting project, and really glad that LakeFS and Delta Lake can actually collaborate together to basically produce the best of the both worlds. And with that, like I said, little tidbit. With that, I did want to hand it back to Karen. Thank you very much, Audie. I appreciate you all. Always appreciate you joining us. So,
thank you so much for having me.
Thanks, Denny. Thanks, Audie. That was a great session, and same. It's always great to hang out and do a tech talk with you and get to talk. So I'll make sure I update the YouTube recording link with the notebook when they pass it over to me. And thank you everyone for joining. All right, everyone, take care. Bye.
Bye.
Take care.